backwards method of finding the perimeter. Like if it was said multiplication, then you did division or something, and then to find the radius, right? And then we use that in the area.
Or shapes. I said shapes, not polygons on purpose in this question, because the maximum area is the circle. If you look at the area they found correctly for this hexagon, so the square is 9. Most of you, I think, found that 9 was a big area of a right-sided, right-angled figure. Yeah, but you can get bigger if you add more sides, and indeed, you get an area of 10.38 for the hexagon, which is bigger than 9. And then her idea was by adding more sides, you enclose more and more area for the same perimeter, and you eventually approach the circle. Right? Yeah, you always make it a tiny bit shorter side that encloses less and less area.
But you can never make it 0.
Not without making two
It has to have
lines.
something.
But doesn't that mean
You can always make it
exceed? You can't go past. You can't get 6. You always have to be below 6 because you can't reach.
Let me think about that. Yes. Right, because you have two sides. So the length can never, when you're pressing on it, the length never gets longer than 6.
Yeah.
It's always a tiny bit shorter than 6, yes. But the area gets infinitely small.
Mhm.
Yeah.
The perimeter.
So you never described what 12 is, so meaning that you could like 12 like nanometer by nanometer by nanometer.
Sure. It's the same principle. It doesn't matter as long as you use the same units for all of your different shapes. If you change units, well, that's.
Well, you never
That's
said
not
the
fair.
12s were the same.
Oh, you mean in these two problems?
Yeah.
Wait, what?
Here. Well, all of them have a perimeter of 12. I guess it was implied that it was the same 12. But you're right. I should have put a unit on the question. That would have made it a little more specific.
I'm finding this triangle since we already have the height and the base. So you would just do base times height, and to find the triangle you divide it by 2, but it's a whole square, so you wouldn't. And so then the area of the square will be 12.5. And then the area is 1 length squared, and so I found the square root of 12.5.
Okay.
Which is about 14.14.
Okay. Good. All right. So you guys can play around with these a little bit on your own. That was a good explanation. So you just save a lot of time. Amy, did you want to add anything to this? Yeah. If you recognize that this is an isosceles triangle, you know, it has 2 equal sides, and you know the relationship of the sides, that can help you also. That's just something that a lot of times people memorize.
Think outside of the dots.
It's really easy.
And so
You just go to page.
oh, I remember
how I did it.
you just have to follow my you have to go way outside of the box.
And then you go back down to the box.
And then
Yeah.
Very good.
They never said that you
didn't
had
finish it.
Well, you connected all the dots. I guess you could make that a circuit if you want one more.
And how many times? No, you still couldn't because the top one might still be on.
You're right.
Yeah.
But I didn't say it had to be a total enclosed group, so, yeah. And I didn't say that you couldn't cross lines or anything like that. Sometimes these problems have further restrictions on them to make them more interesting. Okay, good. And then a couple people recall.
Oh, fractal.
Right, this Sierpinski's triangle, yeah. It's very specific. Oh, you did, lucky you.
Then, and the next triangle was made up of 3 of the first triangles. So that would be 15 triangles, because 5 for this section, 5 for this section, and 5 for that section,
But there's the one in the middle.
plus the one in the middle,
And then the whole thing.
yeah, and then the whole thing.
So
And so that's 18.
I think it's
It's
17.
17. No, it's 15. See, I did my math wrong. 17. I forgot how to multiply. And then the next one, you do the same thing again. So
17 and 17.
17 and 17, plus the one in the middle and the whole thing, which is a large number. That is
Not really large.
not that large, but it is
56.
it's not 56.
It's 212.
It's not 212.
I mean,
times
no.
3.
No, that's 17 times 3. It's 59.
So it would
Wait a
be
minute.
21
It is 17 times
plus
3.
30,
No,
34.
No. Wait,
Which is
what?
51.
No, that's 7.
plus 2. So it's 53.
It is 53.
I got it.
All right.
Yeah.
Okay, and this is a particular, if you see this before, you'll understand how this is constructed.